start explaining the solution in detail. First, some words about Roland DG, just that you know who's talking to you. So Roland DG is one of the leading manufacturers of large form printers. It's founded in Japan in the year 1981 during the first digital revolution. And our goal was always to create digital solutions that make our life or the life of our customers easier. Today we have an installation base of about 150,000 printers around the world. We are available in more than 200 countries and have a net sale of about 340 million euros. Besides being one of the market leaders in the sign industry, we also offer all kinds of dedicated solutions for all kinds of industries. And the haptic proof is one of these solutions. And now we will go into detail. So to understand how it works, I have first to explain a little bit how digital printing is working. I will do this very roughly. And it's very easy. What we have here is we just have a table moving from the back to the front. And at the same time, we have a printhead jetting from the left to the right, from the left to the right, and at the same time, spitting ink on whatever object you have placed on the table. The ink we are using for this application is a so-called UV ink. That means this ink cures when it is exposed to UV light. That is why we have attached a UV lamp on the left and on the right side of the printhead. The advantage for us of the UV ink technology is that you are able to print very thick ink layers, and that's what we need to build up the tactile structure on our substrate. The colors we are using is CMYK, like on the desktop printer at home to print all the color information. But besides this, we also have a gloss ink and white ink. We use the gloss ink to print in multiple layers the structure, the haptic surface. And we use the white ink just to make the colors a little bit more bright, because after printing the haptic structure with the gloss ink, you see that this is a little bit yellowish, and then it is needed to first print a layer of white ink. The printheads we are using are able to print very small dots to achieve the resolution we need of about between 3 and 5 picoliters, and the thickness, the maximum thickness of one layer of varnish is a little bit depending on the printer between 30 and 60 microns. But it's also possible, for example, if you wanted to print leather surfaces where you have a very fine structure, to print with a thickness of only 10 microns, for example. So before I show you a small video that makes the process more clear, I just wanted to review a little bit the pre-press process we have seen so far. So everything started with the meters scan, which delivers, for our purpose, delivers us two important outputs. First is a black and white picture representing the height topography of the surface of the scanned object. White is representing the height 0, and black is representing the maximum height. And on the other side, we have the high resolution RGB color image that we use to print all the color information on our substrate. Before doing this, there's AVA in between. With AVA, you do all the manipulation of the scanned data to your wishes. And AVA is also able to generate all the files you need to send to the Roland printer and to print the haptic surfaces. This was different a few years ago. At that time it was all manual work with Photoshop. So today it's a lot easier to process the data and make them ready to print on our devices. In the middle you can see the end results first of printing all the layers of varnish. In the middle you see then the printed structure with a layer of white, and at the bottom you see the final product with the color information printed on top of the structure and the white. And now I will show you the video. So this is our showroom here in Willich, and you can see the LEF series. These are small flatbed printers which are very often used for this application, but we have also bigger flatbed printers, and some companies are also using bigger flatbeds from Roland to do the same application. So everything starts with the first gloss layer. What you see now is the normal speed. Most of the video we see fast forward, so that the complete video has only a length of 3 minutes, even if the process in real time takes about 1 hour. So for this sample we have a size of A4, and we printed a height of about 600 microns. So it means we print 9 layers of varnish, each a little bit more than 60 microns height. So this is the first layer. I will then only show the fifth, I think it's the third and the fifth layer. But in reality, these are 9 layers of varnish. So now you can start seeing the structure. With the fifth layer, you can already see a lot of the wood structure. Next layer will be the white.
Stefan, can I just ask a quick question on behalf of a viewer?
Sure, Rachel.
Can you explain the minimum and maximum heights that you can get from the gloss layers?
Yes. Actually, we have one printer equipped, in this case, one printer with 2 rows of 180 nozzles equipped with the gloss ink. And if we print out the maximum dot size with both ink rows, the height is about 65 microns. But it's also possible to linearize the output, like you linearize the color to the density. You can linearize the output of the gloss ink to the height, and so it's possible to reduce the ink to the thickness of your wish. And especially for really fine structures like leather, this is also needed.
Thanks, Stefan.
So here we see the close-up of the structure. So in most of the cases, your structures will not have a height of 600 microns. Mostly it will be a smaller height, also due to your production tools, but it's possible to print even higher structures. 1 hour sounds like a long time, but I will shortly tell you about our first customer who requested a proof of a structured wallpaper. It's about 8 years ago. And he requested the sample with a size of 1 meter to 70 centimeter and with a height structure also of 1 millimeter. And we really managed to make a very good, to print a very good structure, and also the colors were good and were matching. And also the customer were really happy with the sample we printed him. And then the customer asked us, how long have you printed on this sample? And we were a little bit ashamed because we were not used to this long time, and we answered 8 hours. But the reaction of the customer was, what? Only 8 hours? We normally wait for weeks until we have a 3D proof of our final product, and it costs us a tremendous amount of money. So it was really that time when we recognized that we found a proofing solution for all the companies producing decorative, tactile surfaces. And today we are we have an established technology. First, we were successful in the wallpaper industry, but very short after the wallpaper industry, the flooring industry was following. And we have also some installations in the automobile industry. There they use this proofing technology mainly to proof the leather optic of the car cockpit. Our customers are using the solution a little bit in different ways. Some are using it in the design process. That's what we have shown you today. Some of them are only using it to make a final proof before creating production tools, which is very expensive. And some of them are only using the digital solution to print the haptic surface without color information, and then they are using these short-term press plate to produce final structure on a print that is done with the mass production printing technology. So this is the way our customers are using this solution. The advantage is that it is very flexible. They can react very fast on complaints of their customers and change things in the design in a quick way. Another important thing is that they don't have to give data to third-party companies to make proofs. They can do it in-house. That's also very important for these sensitive design data. So I wanted to close my presentation with showing you our product portfolio for this application. So we have different printers, mainly different in the size, starting with a width of 50 centimeter up to a width of 1 meter and 60. The length is not that important. So with the 1 meter and 60 machine, it's no problem to print in lengths, for example, 3 meters. We are using special fine art print heads in this flatbed printers to achieve the resolution we needed, because in this case it's most important to be as near as possible to the mass production product. That's more important than speed. And what is also common with all of our printers, they are completely integrated in the workflow with meters and AVA. So these are my last words. Thank you very much. If you are interested in our products, please don't hesitate to contact us.